Everybody for joining for RCR Wireless News. My name is Sean Kinney. I'd like to welcome you to our webinar today, which is designed to examine the ongoing evolutions of 5G and Wi-Fi and how these two access technologies will complement one another over time in a variety of use cases. By way of housekeeping, we've got 3 presentations for you today, and we have time allotted toward the end of the hour for audience Q&A. So please use the webinar portal, submit your questions throughout the conversation. And following the end of the session today, we'll make a video of the webinar available, and that'll also be accompanied by a longer form report, which will be distributed to registrants. So before I introduce our panel, I'd like to provide a little context on where we are today in terms of 5G and its commercial outlook, as well as provide some info on the ongoing work to continually enhance Wi-Fi. So I'll move through this fairly quickly. As you all know, 5G is designed to support 3 primary use cases, which are enhanced mobile broadband, massive support for the Internet of Things, and mission-critical applications that take advantage of ultra-reliable, low-latency communications. Last year, 3GPP finalized work on the non-standalone 5G NR specification, which interworks with the LTE, RAN, and core while adding a new 5G carrier. And then the standalone version was adopted last month at a meeting in La Jolla that outlines a new core architecture. In terms of commercialization, Ooredoo and Elisa have both claimed world's first deployments back in May and June, respectively. Those are both fairly limited deployments that use the 3.5 gigahertz band, limited in geography, and some questions around what the final devices will be, although Elisa used a terminal device from Huawei, and it looks like Ooredoo is considering a tablet sort of device. In terms of the US market, Verizon's looking to deploy 5G fixed wireless access using millimeter wave frequencies to deliver residential broadband service. That'll initially be based on Verizon's proprietary technical forum standard and then upgraded to non-standalone 5G NR. AT&T's promising standards-based mobile 5G in a dozen markets by the end of the year, and Sprint and T-Mobile have both outlined their independent plans towards 5G, but obviously major implications to that plan pending regulatory approval of the proposed merger. On the device side, we're forecasted to see 5G compatible mobile devices enter the market throughout 2019, as well as other types of devices. So over on the Wi-Fi side, we're all familiar with 802.11ac as well as IEEE's Wave 2 variant of AC. There are plenty of devices in the market for both of those, as well as for WiGig. WiGig's been around for some time. Devices are available, but there's been a bit of a slow uptake. This uses the 60 gigahertz band, so there's some clear propagation challenges, which to some extent limits addressable use cases. Next iteration of the Wi-Fi standard is 802.11ax, which is designed to deliver a 4x increase in user throughput, and it's geared towards dense deployment models, including IoT-type deployments. You'll hear more about AX during the presentations that are coming up. And then there's 802.11ay, which is being framed as providing multi-gigabit per second throughput, more so than WiGig, but over a large coverage area. So now I'd like to introduce our panelists for today. First up, we're going to hear from Mr. Bob Horvitz, who serves as a consultant to the Stiftelsen Institute of Management, Innovation, and Technology. And he recently co-authored a paper for the European Commission titled Fixed and Mobile Convergence in Europe. He'll be followed by Derek Peterson, Chief Technology Officer for Boingo Wireless, as well as a member of the Multiplier Alliance Board of Directors. Then we'll hear from Monica Paolini, Principal at Senza Fili Consulting. Monica writes extensively about numerous areas in the telecom space, including 5G, CBRS, edge computing, AI, and Wi-Fi. So a big thanks to our panelists, and with that, I'll turn it over to Bob Horvitz.
Hello, can you hear me all right? Well, you can't, so I can't hear you, so silly question. Sean, move on to the next slide. And actually, that's, I don't know if we need to even dwell on this slide, because I think everybody in the audience is probably familiar with the VNI and the kinds of things they're talking about. Yeah, let's go just past that. No, back one. Yeah, this one. I wanted to draw attention to people to this collection of essays that was published in 2012. Now, 2012 would normally be prehistoric from most people's perspective, but this is really a brilliant summary of the technical side of what is actually involved in cellular Wi-Fi integration. It goes through the standards of cellular and Wi-Fi in great detail, talking about all the interface standardization that's required to get them to communicate. And I really recommend that you take a look at this, even though it's a little bit older now. You can go on to the next slide. I think all of us are going to be talking about different flavors of cellular and Wi-Fi, and whether they're substitutes or complements. Historically, they started off really serving different purposes. Cellular's aim was to make telephony mobile, and Wi-Fi's aim was to make data wireless. And that led to different system architectures and ownership standards. And then also that was reinforced by the fact that they use different frequency bands and authorization frameworks. But as it happens, both of them chose to use packet radio technology, and then the IP suite, which made the possibility of convergence a real option. And now that LTE is starting to use license-exempt spectrum and to aggregate bandwidth from cellular with Wi-Fi, that really is a kind of confluence that requires conscious cooperation. And on the other side, Wi-Fi is gaining cellular-like features with the ability to roam and do handoffs and support mobility, things that it was never intended to support. Now, this is maybe a little more academic than most people in this webinar are interested in, but just to let you know, 3GPP began looking at the possibility of interworking wireless LANs in 2001, which is pretty early. And they proposed this general reference model and more importantly, scenarios for integration. Next slide, Sean. This is from that feasibility study. It's 6 steps basically, from common billing to 3GPP system-based control and charging, and then the ability to use packet switch services from Wi-Fi into 3GPP. And then now in the more serious integration stages, they foresaw the need for service continuity, where you could switch from one medium to the other without having to break off the session. And an enhancement of that is to do it without any loss of data or any interruption in time, so that the user might not even be aware of changing from one channel to another. And the final step is, remember, this is 2003 when this was published. So the final step is giving Wi-Fi access to switch circuit services. That's not very relevant anymore. Next slide. This was the reference model. It's so simple, it's, I would say, rather trivial, but just for historical purposes, I wanted to include it. Next slide. Now here's where it gets interesting. There are 2 standards organizations involved in production of the basics of these 2 media. As you probably know, 3GPP is responsible for developing mobile cellular technology, and IEEE has basically focused on fixed wireless, and that's the umbrella for the development of Wi-Fi and WiGig and things like that. And until rather recently, they just work separately. And that, as a result, it's not a surprise that Wi-Fi and cellular are minimally compatible. That didn't matter when they were in different bands, but when they have to share a band, that really does matter. And now there's some convergence going on between them, but it hasn't actually been managed by the standards organizations actively. They've been sort of passively managing it, and as a result, there's many proposals from the cellular industry about how to integrate Wi-Fi bandwidth and cellular. Some of them are just listed here. There's LTE-1 aggregation, LTE unlicensed, license-assisted access. These are all sort of variants on a similar problem set. And then down at the bottom, there's from the Wi-Fi side, what's going on to integrate Wi-Fi with cellular from the customer's perspective. Next slide. But the story gets really interesting in 2015. The development of license-assisted access really required cooperation between 3GPP and IEEE because they were talking about aggregating bandwidth from the two systems, and that raised questions about fair band sharing and acceptable levels of interference between LTE and Wi-Fi. So in that process, which arguably didn't even succeed that well, IEEE expressed interest in working with 3GPP to develop 5G, and 3GPP responded positively. So they exchanged liaison statements, and then IEEE created a new work group to develop standards for 5G Wi-Fi interoperability and joint use of spectrum. And here's some resources that I have links for if you want to check out what's going on. And just about a few weeks ago, they had a webinar like this one, the IEEE did, on small cells and their role in 5G networks. I think right now the work that IEEE is doing is not all that interesting and not even all that necessary for the development of 5G. The one area where they seem to have a kind of clearly different agenda and are doing useful work is looking at this proposal from India for something called frugal 5G. This is an adaptation of 5G for countries that have lower available capital and don't necessarily have 4G or LTE networks in place at the time that 5G is introduced, and more rural population that might prefer to have access through something like TV white spaces. This is a very interesting project, and I really hope that it's picked up by the 3GPP and they work together to help the unconnected get connected using 5G. Next. Yeah, the report that was just published by the European Commission last Friday raises the question about the design of 5G, which is designed to allocate traffic between cellular and wireless networks using algorithmic methods. And I think this is a very interesting development, but it has political significance as well. The rules for how this is done, the latest version of the rules are here at these two sources. They're two different standards that have just been issued in the last couple of months. But if you want to find out the details of real integration and traffic steering between the two networks, these are the parts of the standard that describe in amazing detail how that will be done. Next slide. But what really piqued my interest was a comment from the 5G work group's roadmap, where they looked at what was going on with traffic steering, and they basically said, well, it looks like 3GPP is going to control access to all other media through the HETNet architecture and provide billing and control services for them. And that's okay with us. That's sort of what the IEEE said. And I was surprised that they, signed off on that so quickly. I would think that they would want to maintain a little bit more autonomy for their access pathway, but perhaps not. I haven't talked to anybody in the organization to confirm that, but that's what they wrote in their roadmap, that they're basically just going to let 3GPP decide whether to steer traffic to Wi-Fi or to steer it to cellular. Now, I think that's going to become as a bit of a surprise to some people. Next slide, please. And this is the report that I was talking about. This was just published a few days ago. It's huge, and I must apologize for the format, not just because there's formatting problems with the page breaks falling in places that we didn't plan, but the European Commission wanted us to do a 6-page executive summary and then a 35-page highlights and then the report itself. So as you read through it, you find the same material repeated, first very briefly and then with a little more detail and then with a lot more detail. And as a reading experience, it's not very good, but we had to do it their way. But it has a lot of information that you might find interesting. Particularly the whole first chapter is devoted to the question of whether fixed and mobile networks today are substitutes or complements. And it's a very interesting discussion in the report, I must say. It was written by my colleague Simon Forge. And then the next chapter is about coverage requirements for mobile. Do they work and can they be regionally harmonized? Then I wrote the section on how much of today's fixed infrastructure can be used for backhaul, and the conclusion is not very much at all. And then I wrote the section also on modernizing the use of QoS, QoE indicators, and that's really the focus of the report. And it lays out a roadmap for how to update the use of indicators, which are now very strongly oriented toward voice communications. And then the other part, which is what we're talking about here today, is blending Wi-Fi and 5G. So check it out. Price is right. It's free. And the link is at the top of the right section of this slide. Next one. So this is basically just the highlight, the stuff that you probably would be looking for and probably would have a hard time finding, because it's 200 pages of report. And as I say, it's got a really complicated structure of brief presentation and then a medium length presentation and then a long presentation. But the essence of what it says about Wi-Fi and 5G is this. Wi-Fi is now seen as essential to 5G to the extent that 5G networks are being designed to control handovers to and from Wi-Fi. And there is a real risk in this process that algorithmic implementations of traffic steering will deprive end users of, first, awareness that they have the choice, and second, the possibility of making the choice of which Wi-Fi network they want to use and when they want to use Wi-Fi and when they want to use cellular. Now, the traffic steering rules are not finished yet, so it's possible that I'm sounding the alarm too early. That's what William Webb has said. He thinks this is a real problem, but that it's too soon to start regulating it. But I just wanted to raise the issue early, preferably while the rules are still being written and not afterwards. But the point that the report makes, our report makes, which is a policy recommendation, is that MNOs should not have complete or exclusive control over their subscribers' access to Wi-Fi, and users must retain the right to select and self-provide wireless LANs for local connectivity and internet access. And cellular use of license-exempt spectrum should not lock out others' ability to use that spectrum as well. And I think that's the last slide, isn't it? No, this is just, there was a review of our report published in Policy Tracker just a few days ago. And I quoted here what William Webb says. If you're European, you probably know who William Webb is. If you're American, you don't. He was director of research at Ofcom UK for many years, and now he's a consultant. And he liked the report, and he thinks that it's the right issue, but again, premature. My view is that this is an issue to monitor and handle reactively, rather than put in place remedies at this early and uncertain stage of the market. And frankly, I agree. And my take on it is that I wanted to raise this issue while the rules are still being written and not after the fact. And that's about all I had to say. And I'll sit back and listen to you all. Thanks for coming.
All right. Thank you very much for that presentation, Bob. And now we will turn it over to Dr. Derek Peterson, CTO at Boingo Wireless.
Well, good morning and good afternoon, good evening, everyone. Happy to join you here. I'm going to take a first approach talking a little bit about 5G, then I'm going to talk about Wi-Fi's role in 5G, and then get into a little bit more details of, you know, convergence and how 5G and Wi-Fi works together. So with that, I'll go ahead and give you a quick rundown of who Boingo is. So next slide, please. So hopefully most people know Boingo Wireless. We deliver Wi-Fi in a lot of the airports. A lot of people end up going into, and that's probably where you remember or ran into us in the past, at least our brand. We've been doing that since 2001, back when, you know, people were carrying around those large dongles and primarily only using laptops. As Bob shared, you know, it was built for that kind of data integrity. We've shifted our models quite a lot in the last 18 years. Now we deliver some of the most largest venues, both Wi-Fi and cellular, and we work and build neutral host systems, taking advantage of all technologies, whether it's Wi-Fi, cellular, and all the different bands and shared spectrum and everything else that's coming out. So that's our goal, is really to work with the venues and then deliver them great connectivity. So with that, going to the next slide, I want to talk a little bit about why 5G is so important. And it really boils down to the future demands more connectivity, and we're utilizing more data every day. I get a question often from people asking, well, haven't we reached the plateau where, you know, 2 megs is enough? And I've had that argument with, you know, people that I would think, you know, have seen the explosion of data and would go, yeah, I need more than 2 meg. And we all know that people are asking more. So on the next slide, what I share is, you know, some of the different things that you've heard possibly that 5G is going to help solve. And I think all of these things are important. I think the key thing for us to remember is we are consistently using more data, and we're consistently wanting better experiences with our networks. When we look back at how the network started, it was, we had you know, our first life, our physical life, and then we had our digital lives, and they were very separate. And then we ended up putting in applications to try to bring that digital and that physical life closer together. Things like Foursquare, where you could go check yourself into a location. You know, and that was a big, huge item, you know, back in the mid 90s and late 90s. And now what we're trying to do is really get immersed inside of our content. And that's what a lot of these new things and are being pushed for, is really trying to get that immersive experience. So 360 video is a good example. Being able to sit in a room and have a virtual reality experience where I'm actually personally inside of a room instead of being able to see a flat screen of a room like what we do today. And when we start doing some of these new technologies and take advantage of this immersive experience, we need better latency, we need faster speeds, and we need all the stuff that 5G is promising. I mean, even with 360 video, if you think you're having, you know, 20 or 30 different cameras and they each only require a meg, you're still talking 30 megs, and you're talking latency on all of those so that you can have that experience. And you're really getting into, in some people's minds, if you wanted it to be immersive, you need to get up to 500 megabit speeds to be able to deliver that. And again, you can go down each one of these cases, but the key thing is we want our networks to be part of our physical world, to bring the physical and the digital world together. And that's the promise of 5G. So if we go to the next slide, we recognize by our Abraham Lincoln that the best way to make that future happen is to create it. And we have a lot of smart people working on it. Bob ended up sharing, you know, back in 2001, you know, reports of trying to create this environment where Wi-Fi and cellular were working together, and there was a bunch of reports created, but those reports didn't go anywhere. And so now it's upon us to really push ourselves so that we can create that future, and we can actually make Wi-Fi and 5G and 4G and IoT and all of these different immersive experiences work together to produce the result we want. And so to make that happen, please, next slide, what we need to do is we need to recognize that making that happen requires all of technology. And so the future still demands Wi-Fi. I've heard arguments that, in the future, cellular is going to take over, and then Wi-Fi is going to be non-existent. I've heard the Wi-Fi guys say the same thing about cellular. And the reality is that to really take advantage of all of the different use cases that are we need to resolve, we really need everything. We need Wi-Fi, we need cellular, we need them to work together, and we really need to work towards that. So I want to talk a little bit about the future of Wi-Fi. So why is unlicensed important? You know, we've seen a lot of different reports, and hopefully you've looked at some reports that show that unlicensed and being able to get access to spectrum without putting in a lot of money allows us to be able to build and innovate. And so we need to continue our innovation cycles that we've had on unlicensed. And the good thing is we've had that with Wi-Fi, and we're moving unlicensed farther with IoT, with cellular now, and we're really recognizing that unlicensed allows us to create new performance layers and levels and create flexibility for all kinds of service providers and all kinds of use cases, because it allows us to be able to innovate. And that's one of the most important things when it comes to unlicensed, is we need to make sure that we work with our different regulatory bodies, that we keep unlicensed as an important part of the capacity that we build into networks for the future to be able to allow us to keep innovating. Next slide. As we move towards 5G, then we also have to recognize that we're moving from where we were before, focused on coverage. It was always about, hey, I need to get coverage. So macro towers and Wi-Fi were used to get coverage in areas to bring digital capabilities. Macro towers across wide areas, the Wi-Fi across, you know, smaller areas inside of our homes and our workplaces and inside venues. But what we're seeing now is that we want more than just coverage. We want improved connect capacities. We want higher speeds, and we need to really increase the densification to get more coverage and more capacity into an area with reduced latency, of course, and more throughput. And of course, always associated with building a network, we have to recognize that there's a cost of ownership of a network, and we have to balance that cost of ownership of that network against the use case that we have that we're applying. And so Wi-Fi allows us to do all of that in unique ways, allowing us to get that densification. You can also take advantage of other small cells or distributed antenna systems that give you that capability on the cellular side. And we've been pushing those out, and we've been doing what I call Convergence 1.0, where you're letting your DAS system or your small cell cellular system sit next to your Wi-Fi system, but you're not slicing and moving traffic back and forth between the different networks. You're treating them basically as separate networks. So as we move forward, we move into the future of convergence, and we start taking advantages of additional technologies and more spectrum. So we get multi-fire, where you don't need an anchor, an LTE anchor, to be able to deploy it. You get into CBRS, where you end up being able to have shared spectrum, so you can use that spectrum for both MNOs to do aggregation on the LTE, or you can use it as a private LTE service, or you can use it as public safety. So a lot of different use cases, IoT, etc. It gives you a spectrum that can be used for everything, kind of like what we've done with Wi-Fi today, and we've bridged out those different areas. You're now going to see with CBRS and these things that additional movement. So as we look forward then to what we're doing, and we look at Wi-Fi specifically, we recognize that the need for Wi-Fi is to be able to create a carrier-grade experience. And so we want network discovery and access and that whole experience that we're creating to be very quality, secure, and manageable, just like what we've built into our cellular networks with the criteria there. We need to build our Wi-Fi networks to have that same carrier-grade functionality. And the good thing is a lot of the work that's being done recently allows that. Go to the next slide. One of the key things that was created was this ability to use the same credentials that we use on our cellular phones, so on our mobile phones, we can use that same credential to be able to log into Wi-Fi. And Bob talked about it. It's called Passpoint or Hotspot 2.0 or lots of different names on there, NGH, Next Generation Hotspot. But the key thing is, once you get somebody connected to the network, so they're connecting to an IoT network, they're connecting to a cellular network, they're connecting to a Bluetooth network, they're connecting to a Wi-Fi network, is being able to steer that traffic across all these different network access appropriately, and having a simple access protocol to do that. And so taking advantage of these access protocols or access control methods is a very important part of what Wi-Fi has done recently. And will help, hopefully we'll start seeing it show up in IoT devices. The same access control method you'll find inside the CBRS and the multi-fire specs for devices, as well as, you know, some of the Wi-Fi specs using eTTLS and eTLS for those devices that don't have a SIM. So this access control method is going to be an important part of the future of homogenizing that to make it very simple. All right, next slide. It's important to also know that as we start making it simpler to use and connect, that we're going to be able to take advantage of some of these different services across both cellular and Wi-Fi and these other networks that are going to come out in the future, our 5G networks and our 5G radios. And so our 5G core and our 4G core and our Wi-Fi core, they need to be able to work together. And we need to be able to deliver an SLA that allows services like Wi-Fi calling to work across all of them. And just, you know, an interesting tidbit, you know, voice over Wi-Fi was started to get pushed out, you know, in 2015, 2016. And what you'll see today is that it's surpassing VoIP traffic, and it's already surpassed the voice over LTE traffic in 2016. Primarily, of course, due to venues. We make a lot of phone calls in our offices and in other venues, and why not take advantage of Wi-Fi connections to be able to make those calls and reduce that load on the macro network so that it can work with the cars and everything else that's more mobile. But very important stuff going on, really, for us to just focus on that convergence and recognizing it boils down to the services we're providing, and recognizing that we need to create networks that allow that interoperability. So when we look at some of the new technologies on the next slide for managing mobile complexity, we see that Wi-Fi has been working on a lot of new improvements. So 802.11r for fast roaming, so we can have this handoff between access points, like what we did back in the 1990s. I remember working for AT&T Win with Anderson Consulting and trying to figure out how to roam from one macro tower to another macro tower. You know, you have a little bit of a longer time in that roaming scenario because you're driving a car, you know, going 50 miles an hour and you're covering a larger area. When you're walking in an airport, for example, your access points, you're having to do that switch over faster and faster. That same technology, we're going to be able to take that, and we can hopefully one day get it so we can use our base stations that shoot up towards the sky on our planes and do that fast roaming. So lots of great stuff being developed there that I think we're going to be able to take advantage of, not only in IEEE, but also in 3GPP. Intelligent network awareness is also an important feature that was introduced in Wi-Fi recently, or in the last 4 years, and that's 802.11k, which allows us to know how one access point is working against another, and so that we can move traffic around so that it works appropriately, so that we're not overloading one access point while another one's not being utilized at all. And roaming behavior, 802.11v does some more improvements in this transition from point to point. All of these technologies are important because what it's leading us to is it's leading us to developing algorithms to allow us to move from cell to cell. And as we go further down the road in 5G, it's going to be macro cell to micro cell to small cell, and again across multiple technologies. Next slide. When we look at Wi-Fi's future, we're also starting to look at not only how do we end up making that transition from cell to cell and taking advantage of the innovation there? But we're also starting to say, how can we end up taking advantage of better spectral efficiency? As we know, LTE does a really good job because you typically only had 10 megahertz of spectrum that you were deploying, or back in the early days. So they have traffic managers to make sure that you're utilizing that cellular spectral areas, those channels, to the best capacity. That same functionality is being built into 802.11ax and is going to end up providing better coverage and capacity for Wi-Fi. In addition to that, we're also looking at, just like LTE is, at higher spectrums in 802.11ad to be able to do short range speeds and maximum speeds up to 7 gigabytes, and there's even standards going up to 24 gigabits per second now. So a lot of improvement there. So we're focused on not only transitioning from one to the other, better spectral efficiency, but also higher speeds when we need them in these shorter ranges. And Wi-Fi is working on all that. But it's important for us to recognize that convergence is crucial. You're doing really good, Sean. You're clicking there right perfectly. So convergence is crucial to be able to make this happen. So when we look at that convergence design, and the next slide, we can see that we want to take advantage of all the spectrum ranges. Each spectrum range, whether it's below 1 gigahertz or between the 1 and 6 gigahertz, where we see most of the stuff happening today, or the 7 gigahertz or 6 gigahertz higher when we're in the 60s and the 38s. The key thing is to recognize that all that spectrum has a use case and there's a reason to deploy it, and we need to focus on what that spectrum can do in those different ranges and, you know, the physics around that. And then we need to, once we've got that down, we need to recognize that it's important for us to take advantage of all the different licensing types. So we have licensed spectrum, we have shared spectrum, and we have unlicensed spectrum. And we need to realize that there's a case for all of them to work together and interoperable and be interoperable together. And there's lots of use cases on that. So when we look at the new connected venue in the future, then what we're going to see is that connected venue in the future is taking advantage of all of those technologies, and it's converging in the in-building space, because we're trying to deliver that immersive experience indoors inside these locations. Again, also across our cities, but inside the venue, we're seeing a very important drive to have this kind of low-cost operation, greater monetization opportunities, and really taking advantage of some of these great technologies that are coming out, like CBRS and multi-fire, as well as these ones that are evolving. So our hyperdense converged networks of the future means no longer just getting our connections from cell towers like we did before, but go ahead and click it one more time, but actually moving towards this 5G convergence across the entire wireless ecosystem, where we've got Wi-Fi in the building, we've got IoT, maybe some 802.11ah doing some IoT stuff, or maybe we're using, you know, some other IoT technology, as well as we're taking advantage of Wi-Fi, cellular, DAS, small cells, and everything that's available to us. So with that, thank you for your time, and I think I'll pass it on.
Yeah, thank you very much, Derek. Appreciate the presentation. And now we're going to hand it over to Monica Paolini, Senza Fili Consulting.
Thank you, Sean, and I'm glad to be here presenting. And I'm going to take a little bit of a different perspective here. I'm just going to look from the top and give you the bird's eye view of Wi-Fi. And to give you a little bit of sort of background here, I've been working on Wi-Fi for a long time, and I was just, I actually had to Google myself because I forgot when that started. And I wrote the first report in 2001 when Wi-Fi was not even called Wi-Fi. So the title was Public Wireless LAN Access, a Threat to Mobile Operators. And it was, if not the first analyst report, well, they told me it was the first. I don't know, but that's what they told me. But it was one of the first ones. And at that point, it was just an entirely new concept. To have a wireless technology for public access? What do you do with data with wireless? So anyway, so if you actually, can you go back? Yes, here. So what I'm going to like to try to do is to go to think about from what Wi-Fi looks from the past, and to try to understand why is this still relevant with 5G. Now, most of the wireless traffic today is actually Wi-Fi, and this is a Cisco CNI, and so you might have seen this data, but surprisingly few people really look at it this way, because we think about cellular data as being such, it's a huge deal, but Wi-Fi carries much more of the wireless traffic, but because it's a more mature technology, because it's deployed in a distributed way, everybody does his own Wi-Fi pretty much. We have a lot of carrier Wi-Fi too, but most of the usage is through a residential or enterprise or venues. It does carry most of the traffic. And in fact, what I would argue is that the reason why wireless cellular data and 4G and 5G are happening today, have happened, is because Wi-Fi taught us about that. The first experience we all have, I think, unless we're incredibly young, is through Wi-Fi. Wi-Fi taught us that wireless data is possible, and it had potential. And I expect that that's going to continue, and I'm going to tell you why in a second. Next slide, please. And just to look at it, what's happening today. Wi-Fi and cellular access are different. We do, to some extent, we do the same things, but the way we use it is different. And this is actually some data that I got from a report that Bob wrote. And so if you look at it here, if you look at traffic, clearly Wi-Fi takes most of the traffic. But when you look at sessions, it's pretty much 50-50. It's closer. And when you look at time, same thing. So what happens is that Wi-Fi, it's really better for the stationary, for traffic that requires a lot of bandwidth, while with cellular, it's more for the mobile access from quick and frequent connections. So when I'm late, I need to send a text, I would probably use cellular. I don't bother with Wi-Fi. If Wi-Fi is available, fine, it doesn't really matter. But if I'm just sitting down and just need to kill a few minutes, then I just download a video on Wi-Fi. So it's just fundamentally different. And so when we look at it, with 5G, that difference is going to stay there, because it's not so much a technology issue. Now, can you move to the next slide, please? So let's see how did that happen. So Wi-Fi initially was really for fixed wireless access. It's still used for fixed wireless access today, but in 1971, the first connection in Hawaii was just, there was no public access, no mobile device there. And then, you see the FCC released the spectrum. There was the IEEE standard in '97. But even that, at that point, Wi-Fi was a wire replacement. You can see on the table on the right. There was no, what is really remarkable about Wi-Fi is that it started off in a sort of a very limited type of environment, and the scope of the use, the application, functionality, the technology has kept growing incredibly. And so what we have today, Wi-Fi on pretty much virtually every mobile device, it was not really part of the initial plan. And so when Wi-Fi, the name Wi-Fi was introduced in 2000, and then you can see here, I'm not going to go through all the details, but there was a lot of there is a lot of incremental changes. And then when the iPhone was released in 2007, that's where the first time we had the sense that wireless data was something useful, that was valuable. Why would somebody buy a phone for it? When the first phone was released, there was not much you could do with with 3G. The experience was quite limited. And I remember doing 3G auctions, and we're trying to figure out what is that people will do with wireless data. It wasn't really clear because there was not a whole lot you could do. And now, we go all the way to now to June 2018, when we had the latest security feature added with WPA3. So what happens with Wi-Fi, it moved from fixed wireless, wire replacement, residential connectivity, enterprise connectivity, then it moved into mobile devices, hotspots, public access, voice, multimedia, and then integration with other interfaces, and I'm going to go back to that later. And then IoT. Today, most of the IoT applications are running on Wi-Fi, not on cellular. And private networks too. When you think about, there's a lot of talk about private networks, but all Wi-Fi is private networks, effectively. Next slide, please. So I'm not going to go into the certificate here. It's just for reference for you. But when you look at the evolution of Wi-Fi, you see a continuous path and a huge amount of flexibility. And I think that this is really an important reason why Wi-Fi has been so successful. When you think about that, on the 2.4 and 5 gigahertz band, which is a limited amount of spectrum, you carry most of the wireless traffic, and it's scheduled to, it's expected to become more than 50% of the all IP traffic in the graph I showed you before. That's quite remarkable. And I think that this is because the standard has been developing continuously, adapting to what's out there, what is the demand. But at the same time, there is a huge commitment to backwards compatibility. So in cellular, you go, 2G, 3G, 4G, 5G, which are kind of self-contained. There is a different brand, a different, it's a different G. But with Wi-Fi, it's always Wi-Fi. So if you ask most people what kind of Wi-Fi access point they have at home, they probably wouldn't know. But the next time they go out and they buy one, they know that the access point will work with whatever they have in their home, with their devices, and it's still going to be Wi-Fi. So they'll pick some functionality, but it's a continuity. And at the same time, from the vendor point of view, or the enterprise, or there are different features, so people can pick and choose what they need, and that means that there is, again, flexibility. Is the same air interface that can be used to support different different type of deployments, and the certificate, it's where you can go and you can find out exactly what's in there. Next slide, please. And so I'm trying to be short so we have time for Q&A here. I think that when we look at Wi-Fi and 5G, there are two elements to keep in mind. There is the differentiation between the two and the convergence. And the convergence is what Derek was talking about. So in terms of differentiation, I think that as we move forward, Wi-Fi and 5G will continue to support a different usage mode, and which is the one that we have today. So not much will change there. So Wi-Fi what Wi-Fi excels at is the indoor stationary use cases where you have high level of traffic. The frequency reuse is very high. So when you look at 5G or even 4G, it's a technology that is spectrally more efficient. So if you have the same amount of spectrum, you can pack more bits in that amount of spectrum on 5G and 4G. And this is because it's dedicated. You have full control. There is no listen before talk. You don't have to accommodate other users. So it's more efficient, but if you look at the sort of nationwide or over a larger area, you can reuse that spectrum more efficiently. So the frequency reuse, it's better because different entities can use that spectrum. So if you are a mobile operator and you only you don't have enough traffic, a lot of the spectrum is basically wasted because nobody is actually using it. So the frequency reuse, and this is why you have so much traffic that goes over Wi-Fi into a limited amount of spectrum, is because frequency reuse is so high. You have, and as a result of that, you have high capacity, the cost per bit is lower, and you can have both residential and enterprise networks with Wi-Fi. On a 5G or 4G, you tend to have better coverage and wide area coverage, and you tend to have more. It's obviously better suited for public networks. Now, Wi-Fi is cheaper on a per bit cost, but 5G and 4G in general cellular have it's a high value bits that are good at transmitting. So when I'm late and I need to send a text urgently, that I know that cellular will be everywhere, and so it's I need very few bits, but they're very valuable to me. So there is a difference there, and that it's important to keep that difference because we need wireless networks to do all sorts of things for us, and so we need both. However, it's also important to keep in mind that the two technologies are converging. So there is an integration between the two of them. And then with edge computing and distributed networks, what you have is that the local infrastructure at the edge can support both. So you can have edge computing that supports both Wi-Fi and cellular. When you think about, there's a lot of talk of distributed networks, but Wi-Fi is a set of distributed networks. Same thing with private networks, IoT. This is something where cellular is becoming much more like Wi-Fi. At the same time, Wi-Fi is becoming more like cellular in the sense of managing traffic in more sophisticated way, which is what Derek was talking about, and also using and also both are using unlicensed access. And finally, the offload that traditionally is Wi-Fi offloads 5G, we're starting to see that there is a mutual offload because sometimes you want to offload from Wi-Fi to 4G and eventually 5G. So they're coming together in interesting ways. Next slide and final slide here. My sort of final message here is that both Wi-Fi and 5G are necessary to realize the IMIT 2020 vision. And so on one hand, Wi-Fi meets most of the requirements for IMT 2020. Now, the same thing can be said about 5G. It meets those requirements, but not all of them all at the same time and all the same bands. So you need both to have them together to meet all those requirements wherever needed. So for instance, low latency, the extremely low latency, you only need it in some cases. You don't need it all the time, but you need to be able to do that. But the real reason why you need both is to be able to do this on scale. So both Wi-Fi and 5G would be able to support most of the use cases if cost and scalability and capacity were not an issue. But because we have such massive we expect to have a massive use of both technologies, you need to have both because each one of them is not sufficient. And it's important that they're integrated because if you integrate between the two, then you can get better use of your resources. So that's all from me. So I hope we still have time for some questions. Thank you.
Thank you very much, Monica. I think we've got a few minutes here for questions, and we've got lots of good ones from the audience. So I'll try to get these out here as quickly as possible. Derek, for you, one of our viewers wants to know, to what extent can we integrate voice over Wi-Fi with 5G for indoor coverage and capacity?
Yeah, so the interoperability of 5G to other use cases is still being worked on. So when 3GPP did the work, they've relaunched two pieces of work. There's the 5G NR and the 5G in our standalone and non-standalone mode. there are sub cases in there about being able to roam from a 5G to a 5G network and a 5G to a 4G network and a 5G to a Wi-Fi network. And those standards have yet been finished. So I think we're at least a year out. They're talking about working on some of the other use cases by December, but 3GPP has pushed those use cases of interoperability with those out to probably next year. But yes, it's in the plan. That's the total plan, is that all of this stuff works together.
And kind of ancillary to that, Monica, when you mentioned that we're seeing convergence of cellular and Wi-Fi at the radio access network, one of our viewers asks, will we see physical integration of Wi-Fi together with 5G radio heads at any point?
I don't know what physical means, in the sense that it's going to be the same box, and in some cases it is. So you can have it in the sort of like in the same enclosures, the same hardware. However, in many cases, because the propagation is different, you don't necessarily want to do it. So if you have an enterprise, so let's say you want to have Wi-Fi and CBRS, the frequency are different. So, you might, in some cases you want to collocate, so that, and because it helps with the same backhaul, and you might have even the same box. But, for optimal coverage, for optimal RF planning, you might not want to do that, because the density of the access points with CBRS and Wi-Fi, for instance, might be different.
Yeah, I mean, I'll add to that. One of the things that we're seeing is some companies, I probably shouldn't list names, are developing what's called vRAN or virtual RAN technology. And what that allows you to do is use the same antenna and then push different frequencies across, kind of like very similar to a DAS network, where you're using, a baseband unit and you're pushing out to the antennas, multiple different frequencies after you combine them. But doing the same thing, vRAN, across all spectrums, so all the way down to 600, and some of them are working on solutions all the way up to 28s, 38s, and those higher bands, and the gigahertz bands. So again, it really boils down to the use case. I assume that those systems are going to, depending on how they're built and the costs that come in, and the amount of space they require, speed and all those other things that we're talking about, and power requirements in that venue. But I do think that there'll be venues where we'll see combined equipment.
Right. And a question for Bob. I know that you wrote extensively about network densification in your report that you mentioned. So one of our viewers is curious how Wi-Fi networks can be leveraged as operators look at small cells and femtocells to densify their cellular networks.
I'm not sure I understand the question. I don't know. Could you could you clarify what you mean there? I don't get it. There's a lot of carrier Wi-Fi.
I think that's what the question is around. Is can carrier Wi-Fi networks be leveraged as they densify their cellular network?
Let me go back to a report that Monica wrote a few years ago, because it was really interesting. She looked at the economics of small cells. She looked at LTE, small cells, Wi-Fi, and then combinations of Wi-Fi and LTE. And she can address this better than I can, but the conclusion was that the combination of a small cell with both Wi-Fi and LTE is the one that works the best. And I know that from the failure of femtocells as a marketing effort, Wi-Fi just beat the socks off of it, because you get much more versatility at a much lower cost. And so I think carriers need to think about combining Wi-Fi with small cell 3GPP technologies if they want to get their foot in the door, if they want to have people accept them in their homes and offices. People were not very happy with the idea of getting a femtocell and then having to pay the backhaul, but they do it all the time for Wi-Fi. And if you have a box that has both Wi-Fi and LTE in it, or 5G in it, I think you're going to find that people, or the users, are much more willing to pay for the backhaul out of their own pocket. So I don't know, that's maybe not answering the question, but that's how I look at it.
Yeah. Yeah, I'll add to that too. We're doing it today. So we're working with carriers and we're working with our venues where we have Wi-Fi deployed today. And when we go through our upgrade cycle for the Wi-Fi, we're also looking to deploy the cellular alongside with the Wi-Fi. So there's different OEMs that have different solutions that have them combined. And we're taking advantage of that today. And again, you can a lot of the new DAS systems go up there as well as these vRAN systems, and then also small cells where you can take an existing, for example, an existing OEM's access point, Wi-Fi access point, and you can connect directly to that access point using the same power and same cabling and connect on a cellular node. So lots of solutions out there, and if you're deploying networks today, and you're deploying Wi-Fi and or cellular, I think in the future you're going to do, if you're not looking to deploy Wi-Fi, cellular, and IoT inclusive in that, then you're going to end up having to do yet another cycle. So you might as well do it now.
Derek, one thing that came up a few times during the presentations was multi-fire and IoT. This essentially brings cellular into totally unlicensed frequencies, but I was hoping you could maybe give us a quick update on Multi-Fire Alliance's 1.1 specification and how it speaks to IoT deployment scenarios.
Yeah, so good news for everybody. The Multi-Fire has been working on a spec, and if you haven't had a chance to read the 1.0 spec, it's been out for a little bit over a year, and it basically takes the 3GPP LAA spec, and adds to it basically a requirement so you don't have to have an LTE anchor through a licensed spectrum. So in the 1.1 spec, the focus was recognizing that it might take longer to get the 5 gigahertz capability into the cell phone because you're going to be running both Wi-Fi and cellular and the same chip, and then each of the mobile guys are going to have to write logic and policy and managing that. We recognized that a quicker way to be able to get the Multi-Fire out was to focus on that unlicensed in the IoT area. So there was additional work done in the 1.1 spec to focus on how to make sure IoT devices would work utilizing an LTE core and in unlicensed LTE. So that 1.1 spec is due for release here real soon, and again we'll plan on making it available to everybody. And you'll see some devices already pre 1.1 out by some companies in Asia where they've already released some of that equipment, and it's being deployed today mostly in Asia, but our hope is that we start seeing deployments towards the end of the year and beginning of next year, in other countries and other locations.
All right. Well, all three of you brought it up in your presentations, and that's this idea of convergence. So I certainly think that's an apt description for how 5G and Wi-Fi will interact with each other over time as they continue to develop. Unfortunately, we've run past our time allotment, so I want to thank everybody that viewed into the webinar today. For those questions that were submitted that we weren't able to answer, I'll try to follow up with you individually. And a big thank you to the panelists for such an engaging and informative discussion today.
Thank you.
Thank you.
Thanks and goodbye.